Hello, everybody. Okay, so these, or this skill 6, is in relation to the greatest integer function. And what that function does is it takes the input, okay, so whatever value we use for x, and it rounds it to the nearest integer. But be careful because it's the nearest integer that is not larger than the input itself. And that's super important. Okay, not larger. Notice there is a big distinction between this and the absolute value. They are not similar. Absolute value function uses vertical bars. The greatest integer function uses brackets. So please, I cannot tell you how many times students graph the wrong function because they didn't take the time to really look and see, oh, are they vertical absolute value bars or are they brackets for the greatest integer function? Please don't fall into that trap. Okay, so let's calculate. If I have 2.7, okay, let's say I've got 1 and then 2 and then 3. 2.7 is right about here. And we read a number line from left to right, right? So I'd be traveling, la, 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 stop at 2.7. What is my greatest integer? Have I reached 3 yet? Nope. Sorry. You're close. You could be 2.99999 and you still aren't at 3. So some like to call this the fallback function because you fall back to the closest integer that isn't larger than you. So the integer of 2.7 is 2. The greatest integer. The greatest integer of 4 is 4 because 4 is an integer. The greatest integer of 0.3, yep, it's 0. We haven't yet gotten to 1, so it's at 0. The greatest integer of -3, it's not 3. We're not talking about the absolute value. We're not talking about the distance from 0 on the number line. We're talking about the greatest integer. And since -3 is an integer, its greatest integer is itself. But what about -5.4? Let's take a look at this. Okay, there's my number line. You don't have to draw a number line. I like it for the visual in case I need clarification. -5.4 is right about here. And again, we're traveling along the number line from left to right. Have we reached -5 on our number line? No. And in fact, -5 is larger than -5.4. So the greatest integer for -5.4 is -6. Please be careful with those negative values when calculating the greatest integer. Okay, so what in the heck does this graph look like? Well, let's see. I don't know why my tablet is so slow. Sorry, guys. Okay, well, let's say that we start at 0, okay? What's the greatest integer of 0? Kind of a trick question because the greatest integer of 0 is 0, right? Okay, so let's go ahead and put a closed circle at 0. In fact, I am going to move it a little bit from my chart. I'm going to put it in the center. Okay, well, what about 0.1? 0. What about 0.8? What's its greatest integer? Yep, 0. What about 1? The greatest integer of 1 is 1. So that means that every number in between 0 and 1 is included right here, right? But then at 1, I don't include it because I jump up to 1. The greatest integer of 1 is 1. And then I continue on from there. Okay, so what about 1? Oh, what about, going back to the black marker? There we go. What about 1.5? Yep, greatest integer is 1 because we haven't gotten to 2 yet. What about 1.9? Still 1. What about 2? Now we jump to 2. So as I'm extending out to the right-hand side for the greatest integer being 1, I include all of those values that are getting really close to 2, but I don't include 2 because the greatest integer of 2 is 2, and the pattern continues this way. Okay, well, what if I said negative 0.9 or negative 0.5 or negative 0.1? All three of those, have they gotten to 0 yet? No. So this is -1 for its greatest integer and so forth. So working backwards, the greatest integer of -1 we know is -1 because that is an integer. But everything between -1 and 0 has a greatest integer value of -1 until we get to 0. Then we jump to the next step. So ladies and gentlemen, this is our greatest integer function. I'm just letting that set in for a little bit. Notes about the graph, you could say that it starts at the origin, because I always will for you. That it's often called a step function. That the length of the step extends to the next integer and then jumps up. That they are horizontal steps. All of these you can write down. So take a second and write some reminders to yourself, some characteristics, some notes about our greatest integer functions graph. And then we'll move on. Okay, so looking at these, we need to note similarities and differences to understand how each of these different values is going to affect the graph. Okay, well, think about if I were to make an X and a Y chart, right? And I substitute in 0. All right, well, for this first example, that means that I have negative times the absolute value of 0, but that's just 0, which we can't have a -0, so it's 0. All right, let's go about a half step, so 0.5. If I take y, set it equal to a negative absolute, whoa, I just said absolute value. That's so bad. I just did what I told you never to do. Epic fail. Let's rewind. If I were to take 0.5 and substitute it into the greatest integer function, hello Patterson, then that means the greatest integer of 0.5 is 0. So again, we get 0. All right, so right away I can tell that I'm still extending out like I normally would from the beginning, right? From the parent function. That doesn't change. Well, what happens when we jump to the next integer of 1? If I substitute 1 in for the greatest integer, we know that that corresponds to 1, but there's a negative on the outside. So then it corresponds to -1. Oh, that's interesting. Okay. What about 1.8? Well, if I have a negative on the outside of the greatest integer of 1.8, and we know that the greatest integer of 1.8 is 1, I see this now. So I can, just because I know the behavior of the greatest integer function, come to the conclusion that if the greatest integer of 1 in this particular example is -1, I'm going to extend out to the next integer. And this pattern is going to follow. Now let's say, I'm not really sure about the other direction. Okay, pick a number. Let's say -2. If I were to substitute that in, so negative, greatest integer function of 2, that corresponds to not, oh fudge, maybe if I plugged it in the right way, right? That would correspond to a +2. Because the greatest integer of -2, here I'll write it out so you can see the full, is -2, which then leads us to, yep, interesting. Okay, so then 1, 2, 1, 2, the pattern will follow. Okay, so it's safe to say that if there's a negative on the outside of the greatest integer brackets, that it changes the direction in which the steps are going. Instead of going from left to right up, they're going from left to right down. Okay, let's take a look at B. I'm going to kind of section it off here. Okay. Now, notice the negatives on the inside of the greatest integer function brackets. We just talked about absolute value in class, so that's why I keep tripping up. Sorry, guys. Okay, well, always 0, right? But you can't have a negative 0, so this just stays 0. But what about 0.5? Well, if we were to substitute 0.5 in for x, even though my input is 0.5, when we substitute that into the function, we're getting a negative 0.5 inside of the brackets. And that correlates to negative 1. Oh, that's interesting. Okay. What about 1? Well, if we substitute 1 in for x, we get the greatest integer function of an, ooh, and that's negative 1. Gosh, I wonder what's happening. Okay, let's go the other direction. Let's do a negative 0.5. Okay, if we substitute that in, we get y is equal to the greatest integer function of a negative 0.5, which becomes a positive 0.5, which then goes to 0. Interesting. Okay, let's try one more. Negative 1. If we substitute that in, we get a negative 1, which is the greatest integer of 1, which is 1. Okay, let's sketch this and see what conclusions we can make. Okay, 0, 0, right? But then it extends, well, we'll just plot these points. And then 1/2 is at negative 1. And then that's at negative 1. And then negative a, oh, do you see what's happening here? It's extending in the opposite direction. Interesting. So let's draw in a few more steps here. Okay, so differences and similarities, right? Well, let's see, we'll go back to black. Differences and similarities. I definitely say that a similarity would be both decrease from left to right. From left to right. Okay, both, notice, instead of going from down to up as we go left to right, they're going from left to right down. They're decreasing. Okay, so that would be a similarity. Any other similarities? The step length is still 1 unit. And the space or the height between steps, or the distance, I'll use distance. The distance between steps is still 1 unit. Now, our big difference is that A, the circles go from closed to open. And on B, the circles go from open to closed. You could also say, if this helps you to see, that they all start at 0, 0, right? So both, sorry, I'm smushing it in here. Hopefully your notes look nicer. They both start at the origin, but B extends to the left. Okay, so B is extending the closed circle to the left. A is extending the closed circle to the right. Okay, so if that helps, you can say that as well. So A extends right, and B extends left. These are all different ways to help you remember what graph is going to do what, or which graph is going to do what, okay? I'm changing my color real quick. We will go to, I know it doesn't matter, just choose a color. Okay, we'll do red. This, when the negative is on the outside, is called a vertical reflection. We saw that with our absolute value functions. And then if the negative's on the inside, so inside of a parenthesis set, or inside of, in this case, the bracket for the greatest integer, We call this a horizontal reflection. And that actually makes a heck of a lot of sense, because if you look at the original, if I were to reflect that horizontally, reflect it across my y-axis, the circles would go to the left. They would reflect in that direction. Woo! All right, nifty, nifty. Okay, let's take a look at this one. Let's take a look at C. So now we've got C and D. There's a 2 on the outside and there's a 1/2 on the outside. What's it gonna do? I know. Yeah, not funny. Okay, so here's X and Y, always starting with 0. If I substitute in 0, we get 2 times the greatest integer of 0, which we know is 0, so that still works out to be 0. Okay, if we substituted in 1, we would get 2, because we know there isn't a negative, so we know we're extending to the right. None of that is changing, but the 2's got to have something to do with it, right? So 2 times the greatest integer of, well, the greatest integer of 1 is 1, and then if we multiply that by 2, we get 2. Okay, so something I want to test is if we were to use 0.5, because that's a big jump between 0 and 2. Okay, let's see. 2 times the greatest integer of 0.5. Well, we know that the greatest integer of 0.5 is 0 because it hasn't reached 1 yet. So 2 times 0 is 0. Okay, I think I have an idea, but I want to try one more thing. So let's do -1 and see what happens. So y is equal to 2 times the greatest integer of -1. Well, we know that that's the greatest integer equivalent of, and so this is -2. Yep, it appears to me, ladies and gentlemen, that if we go from 0 and we extend out to 1, we still have an open circle, just like we saw before. But 1 now correlates to a y value of 2. And then we still extend out 1 unit, but our step jump is 2 units. Interesting, because, and we can test that too, -1 as an x value correlates to -2 for y. Okay, so if there's a 2 in front of our greatest integer brackets, that means we're going to go 2 units up to the next step. Well, let's test that out for 1/2 and see if that has the same effect. X and Y chart, and we'll definitely include a 0, okay? So if we substitute 0 in to our greatest integer bracket, we know that the greatest integer of 0 is 0 times 1/2 gives us 0. Okay, no big surprise, right? Well, let's try 1. If we substitute 1 in for the greatest integer, and then we multiply by 1/2, we get 1/2. So 1 now corresponds to a y value of 1/2. Let's see if the same thing happens for -1. Okay, y is equal to 1/2 times the greatest integer of -1, which we know is -1 times, oh, yep, the same thing happened. So 0 still corresponds to 0, so we didn't shift, right, up, down, left, or right. But then we extend out to 1, open circle, because at 1, what's the corresponding y value? It's 1/2. I need to make this a little bit bigger. And I extend out, open circle. -1 corresponds to a -1/2, and then at 0 it changes. So I am just going to draw a few more steps in here. When these intervals get really tiny, I would say try to do like half the distance. Some of them will get as really, really tiny. And just give me like 4 or 5 steps so I can see that you understand where it's supposed to go. Please. All right. So similarities first. I probably shouldn't abbreviate. Okay, so similarities. The steps are 1 unit in length. So step length is still 1 unit. And what else is similar? They are increasing from left to right. From left to right. Okay, another similarity is that the circles extend right. So closed to open. And it starts at 0, 0. There wasn't any shift. Okay, now the big difference, big difference is the length between the steps. We'll say distance, not length. Distance between the steps. And the reason is because, and we actually did see this with our absolute value, if there's an A value, it's going to vertically stretch or compress. So for this one, we're going to say since A is 2 and it's greater than 1, it is a vertical stretch, which we can see. We're stretching the graph so that there's 2 steps in between, or sorry, 2 units in between each step. And for D, since A is 1/2, it is a vertical compression. A is between 0 and 1. So we can see that it is pressing the steps closer together. The distance between the steps is smaller. All right, let's keep trudging along. We've got 2 more. We can do it. Man, what's this going to do? Okay, so let me go back to my blue. For E, we can see that there is a 2 inside. Okay, so let's make our X and Y chart. We got this. X and Y chart. I'm still going to use 0. Now, if we substitute 0 in for X, 2 times 0 is 0. We know the greatest integer is 0. Okay, so we're going to have a value there. What if I use 1? Sorry, negative 1. Well, Y would be the greatest integer of 2 times negative 1, which then leads us to the greatest integer of negative 2, which we know at this point the greatest integer of negative 2 is negative 2. So negative 1 then corresponds to negative 2. Interesting thought, right? Well, let's pick negative 1/2 to see what the behavior of this function is halfway between 0 and negative 1. So if we substitute that in, we get 2 times a negative 1/2. Oopsies. Okay, so then that, if we multiply, that's the greatest integer of negative 1, which we know to be negative 1. Ooh, let's go the other direction. Let's say 1. If we substitute a positive 1 in, that's 2 times 1 in our greatest integer brackets. So the greatest integer of 2 is 2. Same thing's happening, but on the positive side of the number line. All right, what about 1/2? We get y is equal to the greatest integer of 2 times 1/2, which is the greatest integer of 1. Same thing happened. Okay, so graphing, we start at 0, 0, right? We extend out, but then at 1/2, we have to jump up to 1, and then at 1, we jump to 2. Let's see if I can do it. Okay, negative 1/2 correlates to negative 1, and then negative 1 correlates to negative 2. The same thing's happening. So it appears that when there is a 2 inside of our greatest integer brackets, it shortens our step length. Very interesting. A little bit strange, right? We haven't really seen that. Well, let's see if that shortens. What the heck is 1/2 gonna do? Some of you might have your thoughts. Let's check it out. Okay, our X and Y chart, always with 0. If we substitute in 0, we get 1/2 times 0, which is 0, and the greatest integer of 0 is 0. So many zeros. Okay, if we choose negative, well, I don't want to do a negative 1/2 again because then we're multiplying 1/2 times negative 1/2, and that gives us 1/4. So let's just jump to -1. Okay, so y is equal to the greatest integer of 1/2 times -1, which is the greatest integer of 1/2, which is, yeah, that's -1. Okay, well, that's normal. Let's keep going. What about -2? Do we think this will be 2? Sorry, -2 like it was? Maybe. Okay, so if we substitute in, we have 1/2 times a -2, which then leads us to, 1/2 times 2, right? And it's negative, gives us -1. And the greatest integer of -1 is -1. Interesting. Okay, I'm going to extend my x and y chart up because I want to see what happens at -3. Any guesses? Well, I'm certainly running out of room up top, so let's go down here to separate out. Okay, so y is equal to the greatest integer of 1/2 times a -3, which gives us the greatest integer of -3/2, which is a -1.5. So it hasn't reached -1 yet. This corresponds to -2. Wow, that's interesting. Okay, what about +1? If we substitute in a +1, we get 1/2. We know that the greatest integer of 1/2 is 0 because it hasn't gotten to 1 yet. Well, let's try 2 and then we'll sketch it out. If we substitute in 2, we have 1/2 times 2. That gives us 1. And the greatest integer of 1 is 1. Let's graph it. So 0, 0, right? But at 1, the y is 0, okay? At 2, it goes up to 1. So it must extend out and then open circle. At -1, it corresponds to -1. Same with -2. But then at -3, it's -2. So this must extend, it must extend out 2 units. Very interesting. Okay, so let's talk about similarities and differences. So similarities between E and F. And I know I abbreviated similarities in the first one. I apologize. Okay, so the first similarity is that they start at 0, 0. Okay, so there wasn't a horizontal or vertical shift yet. There wasn't any translation. They start at 0, 0. They increase from left to right still, so there wasn't any change in growth. So in other words, where our steps were going as we increase, so increase from left to right. The only time that we saw that change was when there was a negative involved for A and B. The circles extend to the right. Extend to the right, and they go open to close. Again, the only time that we saw this change was in A and B when there was a negative involved. And the distance between the steps is still 1 unit. The only time that we saw the distance between the steps change was in C and D. Okay, so the big difference is the step length. And we can say that, because this is our B value. We saw that in the last set of notes for skill 5. I think it's fair to make a conjecture that if B is greater than 1, the steps got shorter. And when B was between 0 and 1, the steps got longer, which is different than what we saw with vertical, right? When the A value was greater than 1, we stretched. Well, here it's reversed. And something to note, let's see, where's my red pen? Something to note is that we didn't use 2, right? For example, E, our steps didn't extend to 2 units. our steps extended by a half, so they shrunk. So let's make a note that the step length was affected by the b value's reciprocal. Okay, so we can even put in a thought bubble. I haven't done those with you guys yet. I love my thought bubbles. We can say that for E, the 2 actually shortened it. And then for F, the 1/2 actually lengthened it. We got a lot coming at us, you guys. This is good stuff. I will see you in the next set of notes. I don't actually know where my paper just went. Oh, good. There it is. Okay, bye.